A chi-squared test for independence is used when we have two categorical variables and we're looking to tell if they're related somehow. That is there an interaction between these variables, meaning they're dependent, or is there absolutely no association or relation between them, meaning they're independent? Chi-squared tests for independence are going to rely on a contingency table, which means our very first step before we even do the test is to go ahead and find what are called our expected values. There'll be a separate video explaining how we do that. We find the expected values because it turns out we have some assumptions we need to meet in order to be able to even run a chi-squared test for independence. The first assumption is what we call the 10% rule. And that is, when we look at our sample, it can be at most 10% of our actual population. So that is, we have a restriction on how big our sample can be. It can't be like 20 or 15% of the population. At max, it can be 10% of the population. Another assumption we have, where this limits how big it is a restriction on how small it can be. That is, we need our expected count to be at least 5. Now, there's a little bit of a caveat to this, and that is it's okay for maybe 1 or 2 of our expected counts to be under 5. At most, 20% can be under 5. So that is, if you think about a contingency table that has 4 cells on it, we can't have any of those cells under 5 because 1 out of 4 would be 25%. So once again, we're hoping all of our expected counts to be at least 5, at most 20% under 5. Now, if we meet those assumptions, we can go ahead and start our test. The first step to our test is to list, and we'll list R, which is the number of rows in our table, and C, which is the number of columns in our total. These do not include totals, so that is only where the data is. I use these to calculate degrees of freedom, and degrees of freedom for chi-squared test for independence is C-1 times R-1. After I've calculated my degrees of freedom, the next step is to go ahead and find my hypothesis. My null hypothesis is that my variables are independent. That is, I'm going in running on this idea that there's no relationship between them. I'm trying to prove the opposite, that is, I'm trying to prove they're dependent. After I've listed and come up with my hypothesis, the next step is to go ahead and find my test statistic. Just like a chi-squared test for goodness of fit, my test statistic is chi-squared, and that is sigma, or the summation of my observed minus my expected squared all over my expected values. So once again, sigma adding up, my observed minus expected, I square them so that they don't cancel each other out, and divide by my expected to find the ratio, or the relative deviation. After I find chi-squared, the next step is to find my p-value. And the fifth step is my conclusion. My conclusion fits the same basic model all of my hypothesis tests have. That is, I compare my p-value to 0.05. If my p-value is less than 0.05, I will reject H0. What that means in this hypothesis test is I'm rejecting the idea that these are independent. If I'm rejecting the idea that they're independent, that means there is enough evidence to say they're dependent. That is, I'm saying that, in fact, my variables are somehow related to each other. The other option is if my p-value is greater than 0.05. This would mean I fail to reject H0. What this is telling me is there is not enough evidence to suggest they're dependent. And we need to be careful here, because what I'm saying is there's not enough evidence to suggest they're dependent. This means they may be independent. In no way do I claim for sure they're independent. I say, okay, can't prove they're dependent, maybe they're independent. This outlines my 5 steps for my chi-squared test for independence, as well as the assumptions I need to make so that my test works out.